Assalamualaikum to Dr. Hamidun. My name is Nur Hasinta Mutimakta. My matric card number is AP190267. Today, my friend and I will briefly explain Chapter 4 of Permeability.
Hello to my lecturer and my friends. My name is Tuimuno, metric number AP190262.
In this video, we will explain about what is permeability, importance of permeability, Darcy law, factor affecting permeability of soil, and laboratory testing. What is permeability? It is property of soil which is permit the flow of water. Permeability is defined as the property of a porous material which permits the passage or seepage of water through its interconnecting void. It is a very important engineering property. The importance of permeability is, first, the design of Earth that is very much based upon the permeability of the soil used. Second is estimating the quantity of underground seepage. Third, the stability of slope and retaining structure can be greatly affected by the permeability of the soil involved. Fourth is filter made of soil are designed based upon their permeability. So this is Darcy law. So let me show you how to calculate or how
and
to
he gave
use
some relation by
Darcy
conducting
law
some tests.
formula.
So I'm just explaining in brief what kind of test he conducted. So if it is a soil sample and if we insert a piezometer in the soil at this point and at this point and it is on some datum, so the water will take place. So this piezometer will give us a pressure head, and from the datum if we measure the total head, and let's say total head here is H1 and total head here is H2. So the flow will take place because of the difference in this total head. So the difference in total head, let's say that is delta H, H1 minus H2. So flow will take place due to this pressure head, and let's say the length of flow is L. So and this is the soil sample of area A. So he concluded that the discharge through this soil is proportional to this hydraulic head and inversely proportional to the length of flow and again proportional to the area of flow. So this delta H by L here is known as the hydraulic gradient, and this is the area of flow. So Q is proportional to the hydraulic gradient is denoted with I. So Q is proportional to IA. And one more thing to notice here is the main assumption in this is the flow is laminar. So this assumption is valid for almost all the soils except coarse gravel. So if the flow becomes transient, then this condition will not be fulfilled and we cannot use this principle directly. So there is this assumption that flow is laminar. And so this flow comes out to be proportional to the hydraulic gradient times area, and the constant of proportionality here is it is known as the coefficient of permeability. And denoted with K. So Q is equal to KIA, and if we divide discharge by area, so we get the velocity. So velocity is equal to Ki and Q is equal to KIA. And from here we can define the coefficient of permeability as, so it is the velocity of flow under the unit hydraulic gradient. So if we put the I is equal to 1, so whatever the velocity we get, that will be our coefficient of permeability. So its unit is the unit of velocity, and in case of soils it is generally taken as centimeter per second.
I will continue the presentation with factors of affecting the permeability, laboratory tests, and field tests. For the factors of that it affects permeability is divided by 6 factors, which is particle size, properties of water, void ratio, degree of saturation, structure of soil, and stratification of soil. For particle size, the permeability varies approximately as square of diameter of the soil. Formula can be formed like this, which K is coefficient of permeability, D then is effective diameter of soil, and C is a constant number between 100 and 150. Properties of pore water. The properties of pore water are mainly caused by temperature. The permeability of the soil varies directly with the weight of water and inversely proportional to viscosity of the water. Since the temperature mainly affects the viscosity of water, so it will be like this. Temperature increase, viscosity of water decrease, causing the water flow quickly, and the permeability will increase. Void ratio calculates the available area to flow. Coefficient of permeability can be varied as this formula, which E as void ratio. So if the void ratio increases, the permeability will increase. Degree of saturation calculates the presence of entrapped air inside the soil. Formula of degree of saturation is like this, which SR is degree of saturation, VW is the volume of water, and VV is the volume of water and air. The entrapped air can affect the area of flow that will decrease permeability. Hence, if degree of saturation increase, permeability will increase. The structure of soil will affect void ratio. If the structure is flocculated, it will have more space to get inside the hole. So the void ratio for flocculated structure is large. In contrast, the dispersed structure will make the empty space inside smaller and decrease the void ratio. So the flocculated structure of soil is more permeability than dispersed structure of soil. For stratification of soil, refers to the soil formed by the mutual deposition of soil or dust. Horizontal layer can make the water flow freely compared to the vertical layer. So horizontal layer of stratification has higher permeability than vertical layer. Next is the laboratory test. The main purpose of the test is determine the coefficient of permeability of the soil. Laboratory test has two types, which is constant head test and falling head test. For the constant head test, it is suitable for coarse-grained soil or high permeable soil. First, we need cylinder container to fill in the soil sample, high permeable filter disc to prevent soil leak-out, and measurement jar to measure the water that has been flowed out through the bucket. Place the soil sample inside the cylinder container and close it with filter disc on top and bottom of the soil. Calculate the area of soil sample A and the height of the soil sample L. Fill up the water on top of the cylinder container and the bucket until it is full. Open the water tap and let it overflow. Measure the water level between the top of the cylinder and top of the bucket. It can define as difference of energy of the water at two different levels delta H. As you can see, delta H, L, and A are remain constant. We let the water flow be stable so we can measure the time. When the flow was stable, fill the water in the jar and start the timer. Collect the water in the specific time, T, and the volume of collected water, Q, in specific time, T. According to Darcy's law, the formula will be like this, which small q is water flow or flow rate and I is hydraulic gradient. As we get all data we need, the formula we need to calculate like this, which K is coefficient of permeability. Next is falling head test. This test is suitable for fine-grained soil or low permeabilities of soil. The tools we need are cylinder container, high permeability filter disc, and glass tube with a U shape and with a water tap. The shape will be like this. A and L are the same as before, area of the cylinder container and the height of the soil sample. Small a is the area of glass tube. Pour the water on top of the cylinder container. Let the soil be fully saturated and fill it until it is full and overflow. That flow needs to be stable. Next, pour water on top of the glass tube to a specific height and set it as delta H1. Open the water tap and start the timer. After flow stop, set the difference of the energy of water at two different levels after the flow ends at delta H2. The time set from the start to the end of the flow at T2. T1 is 0 because it is initial. A, L, and small a remain constant. According to Darcy's law, formula will be like this. Since the hydraulic gradient is continuously changing, we need to set the water level between delta H1 and delta H2 as H. Calculate for a very short time dt and the head of the glass tube drops dH. Amount of the water drops out in dt as q dt. For the equation, the amount of head of the glass tube drops at dt, negative it because the drop is decreased, is equal to the amount of water drops out in dt. For the calculation, arrangement should be like this. Since all of them is constant except negative dH over h and dt, we can integrate it as from the initial head difference delta h1 and the time t1 to the final head difference delta h2 and time t2. Integrate it and make the final arrangement like this. For the laboratory test, the advantage is low cost and easy to carry out because the tool was very small. But the disadvantage is not accurate to measure because of natural structure factors such as organic matter and stratification. And it is very difficult to correct undisturbed coarse grain soil. For the field test, we have aquifer test and borehole test. For aquifer test, the continuous immersion of wells dug into the bottom of the stratum pumps out the water and observations of groundwater levels in nearby wells. The curve of saturated soil is called cone of diffraction. As we know, the higher hydraulic head flows to the lower hydraulic head, so the water will flow to the hole we dig. The pumping continues until the steady state of prescription is reached, meaning that the curve and the water will be constant, and we can calculate it. For the borehole test, the water is allowed to flow through a fixed column in or out of a test stratum through the bottom of a drain hole enclosed by a pipe casing. The water level inside the pit is maintained and the flow rate required to maintain constant water level is measured.
Alright, that's all from us. We hope you understand what we have explained, and we hope it may be useful to all of you. Thank you.